Hello everyone, welcome back to my presentation. As you all know me, I am Ruchi HP, the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. Today I am here to present about operating system, and today's topic is Semaphores. Contents: Introduction, Types of Semaphores, Semaphore operation, Semaphore implementation, Semaphore application, Semaphore advantages, Semaphore disadvantages, Semaphore versus mutex, Semaphore limitations. Conclusion. Introduction. A semaphore is a synchronization mechanism used by operating system to control the access to shared resources. It is an integer variable that is used to indicate the availability of resource or a number of available resource. Semaphore operation includes wait P and signal V, which are used to acquire and release a resource respectively. Next, types of semaphores. Binary semaphores. A semaphore with maximum value of 1 used for mutual exclusion. Counting semaphore. A semaphore with value greater than 1 used for resource allocation and coordination. Mutex semaphore. A binary semaphore used to protect critical sections of code to ensure mutual exclusion. Semaphore operation. Wait P operation. Decrement the semaphore's value by 1 and blocking the process if the value is already 0. V operation. Increment the semaphore value by 1, releasing a block process if any. Operations are atomic and can be implemented in hardware or software. Here we see the representation wait of S while S is less than or equal to 0 or S equal to S minus 1. Signal S is equal to S plus 1. S is the initialization to the value less than value greater than or equal to 1. Semaphore implementation. Semaphore can be implemented using a simple integer variables and two atomic operation. Test and set and compare and swap. Test and set. Sets a value to 1 and returns the previous value, allowing atomic updates. Compare and swap. Compare our values with an expected values and update it if they are equal, ensuring atomicity. Atomic operation. Weight of S. S value is equal to S value minus 1. If S value is less than 0, add 2 process to S.L. Block end. Signal of S. S value equals to S value plus 1. If S value is less than or equal to 0, remove 0 process P from S.L. Wake up of P. End. Semaphore applications. Process synchronization. Semaphore can be used to prevent race condition and ensure orderly access to shared resource. Producer-consumer problems. Semaphore can be used to coordinate the interaction between producer and consumer. Readers and writers problem. Semaphore can be used to provide exclusive access to shared data for writers and multiple readers. Semaphore advantages: simple and efficient synchronization mechanism can be used for both inter-process and intra-process communication, allows for blocking and unblocking of processes, ensuring fairness in resource allocation. Semaphore disadvantages: requires careful implementation and handling to avoid deadlocks and race conditions, can be prone to errors if not used correctly. Debugging and tracing issues with semaphores can be challenging. Semaphore versus mutex. Semaphore can be used to control the access to multiple instances of resources, while mutex provides mutual exclusion for a single instance. Semaphores can be used in inter-process communication, while mutex are typically used for intra-process synchronization. Mutex generally have a lower overhead compared to semaphores. Difference between mutex and semaphores. Mutex: it is a locking mechanism used to synchronize access to a resources. A thread needs to lock the resources and unlock it as well. Semaphore: it is a signaling mechanism. It uses wait and signal calls. Mutex: it is an object. Semaphore: it is an integer variable. Mutex: it allows multiple threads to access the same resource but not concurrently. Semaphore: it allows multiple resources to access the finite instance of resource. Mutex: it can be released only by the threads that has locked it. Semaphore: it can be released by any process acquiring or releasing the resources. Mutex: it does not have different categories. Semaphores. Semaphores are of two types: binary and counting semaphores. Semaphore limitation. Semaphore values need to be managed carefully to avoid deadlocks and starvation. Inefficient if there are many processes waiting for the same resources. May require additional mechanisms such as condition variables to handle more complex synchronization scenarios. Conclusion: semaphores are a fundamental synchronization mechanism in operating systems. They provide a powerful way to control access to shared resources and coordinate processes. Understanding the different types of semaphores and their operation is essential for efficient and reliable system designs. Thank you for watching this video.